Welcome Year 11 to a continuation of trigonometry. Today we're going to revise the cosine rule, which was covered in Year 10. So let's get into it. Right, first of all, we did the sine rule last class. The cosine rule is also used when your triangle is not right-angled, and we use it when we're given two sides and the angle between those two sides, or we can find angles if we know all three side lengths. There is no ambiguous case, so we don't have to worry about obtuse angles. It will just give us the answer, and there's only one possible answer for questions that have information that uses the cosine rule. So remember, capital letters mean angles, lowercase letters are opposite the angles and match, and they are side lengths. Now, the only mention of the cosine rule on your reference sheet is this one here. The cosine rule can be written many different ways, just depends on which letter you want to start with. It can also be written where you can find an angle, so it's just the same formulas rearranged. Let's just have a look, and I've highlighted them here. Let's just look at what's going on. If you're using the cosine rule in the side length form, if you're finding a length little a, notice you're finding the cos of angle capital A. When you're using the angle rule, if you're finding the cos of an angle, in this case capital A, on the top, you are subtracting the side length a squared. When you're doing angle B, subtract little b, angle C, subtract little c, and so on. Let's get into it. Okay, so we're given a triangle ABC. We know little a, little c, their lengths, capital B is an angle. Let's put what we know onto our triangle. Now, because we know two sides and the included angle, which means the angle between those two sides, we can use the cosine rule to find the missing side over here. So, if I wrote the formula like this, b squared is equal to the other two sides squared and added together, imagine this. Now it looks a lot like Pythagoras' theorem, doesn't it? And as a matter of fact, it is an advanced version of Pythagoras' theorem. He never would have seen this, but that's for another time. So you imagine you've got your sort of Pythagoras theorem start, and then it's minus 2 times these two sides times the cos of the angle between the two sides. I actually don't memorize the formula, I memorize the pattern. It makes it a little easier for me, but as long as you understand what you're doing, you can do it whichever way you like. Now, we know little a, little c, and capital B. Rather than putting all of that into the calculator, and actually rather than writing that line, you could go straight to, and it's not written here, b equals the square root of 5 squared plus 11 squared minus 2 times 5 times 11 times the cos of 73 degrees. And that way, you wouldn't have to write this line here, and you could get the answer straight away on your calculator, and you don't have to take the square root of both sides like I'm doing there. It's a bit like the shortcut for Pythagoras' theorem. But if you want to do it the longer way, that's fine. If you do it as the bit that I've written in green here, you put that into your calculator and you'll get 10.7. So that's finding a side length. Let's now do an example where we find an angle. Well, we've got a triangle, 3 sides, 5 centimeter, 8 centimeters, 11 centimeters, and it says find the smallest side. Before we find the smallest side, let's label our, it says find the smallest angle, sorry. Before we find the smallest angle, we need to actually understand the smallest angle is always opposite the smallest side. The largest angle will always be opposite the largest side, and the angle in the middle will be opposite the side length that's in the middle. So, if we're finding the smallest angle in this case would be opposite side length 5, so we're finding the angle we called C here. So our formula is the cos of C equals the two sides next to C, 8 squared plus 11 squared minus 5 squared, over 2 times those two sides next to C. Now it doesn't matter if you do 8 squared plus 11 squared or 11 squared plus 8 squared. It doesn't matter on the bottom if it's 8 times 11 or 11 times 8, as long as those sides are there. What is important is that you are subtracting C squared, the side opposite the angle. Now, again, you could type that into your calculator as it's written there. I tend to just go straight to that line because I know I have to take the inverse cos, so don't even write that line often. Go straight to this line here, put that into your calculator, and it tells you the angle C is 24.6 degrees. Righto, one bonus question. This is not in your notes. Two rowers, Claire and Pip, set out from the same point. Claire rows north 80 degrees east for 2,500 metres, then Pip rows south 25 degrees west for 1,600 metres. How far apart are the rowers? Well, let's have our starting point, and our starting point will be here. So Claire goes north and then 80 degrees to the east, so she's heading out in this direction. Pip rows south 25 degrees to the west, so she's heading down in this direction. How far apart are the two rowers? If Claire goes for 2,500 metres and Pip goes for 1,600 metres. Well, let's just also figure out some angles here. If that's 80 degrees, we know that there's a 10-degree angle in there. We know that's 90 degrees, because east and south are 90 degrees apart. We know that's 25 degrees. We've got enough information to be dangerous here. This angle that I've shaded in blue is 10 plus 90 plus 25. 10 plus 90 is 100, plus 25 gives me 125 degrees. So, realistically, that's my triangle. There's Claire heading off, there's Pip heading off, and Claire goes for 2,500 metres, Pip goes for 100 metres. That's the angle between them. How far apart are they? Well, we know two sides and the angle between them. We can use the cosine rule. Well, if you want to go and label your sides, you can. You just have to call one side little a, one side little b, one side little c, and I've just done it like that randomly. I could have called this one a, this one b, this one c, or any other combination. But what's important is whatever letter I use here, that corresponds with the capital letter there. So, if I write a squared equals b squared plus c squared minus 2bc cos a, which is the formula on the reference sheet, we plug in our values and take the square root of both sides and get our answer. Remember, I tend not to write that. I tend to write this. I tend to write x equals the square root of 1,600 squared plus 2,500 squared minus 2 times 1,600 times 2,500 times the cos of 125 degrees. Then I don't have to worry about those two lines. I can go straight to the answer. But I don't mind which way you do it as long as you get the answer. So, time for you to have some fun. Enjoy the experience. Bye for now.